This is the diagram of the cascode amplifier you see. So this is going to be, see, this portion is common, this portion is common emitter. Okay, and this portion is common base. How did I say this portion is common emitter, this portion is common base? Here you see the base is grounded. Q2 you see the base is grounded. But in Q1 you see the emitter is connected to RECE and it is grounded. And output I take from common base, because common base is the second stage of my amplifier. You're able to understand? I'm having the amplifiers one above the other. Common biasing VCC, common biasing resistors are all as usual. Whatever we design, we have to include everything. So the upper portion is a common base because the base is grounded. And the lower portion is common emitter because the emitter has a bypass capacitance CE parallel to RE. Okay, so VCC, you know, this is the load from which output you take. This is the biasing resistors for common base. This is the biasing resistance voltage divided bias for your common emitter amplifier. You have bypass resistance here. You have coupling capacitance, input voltage, other things are there. So AC equivalent circuit, you know how to draw. You have to short circuit the DC supply and you have to short circuit all the capacitors. And once you draw the AC equivalent circuit, from that you are going to draw the H parameter equivalent circuit. So this is the AC equivalent circuit you see. This C2 capacitor is shorted. This VCC is shorted. This RE parallel to CE is shorted. C1 is shorted. This VCC is also shorted. So whatever DC voltage I have shorted and other things I have drawn here. And you have this base grounded, this emitter is grounded, and you have this biasing resistors RB alone present across the base. So this is going to be the AC equivalent circuit. From the AC equivalent circuit, I can draw the H parameter equivalent circuit. Since you have two transistors Q1 and Q2, I'm representing the current by IE1, IC1, IB1 is the current for the transistor 1, IE2, IC2, IB2 is the current for the second transistor. Okay, from this diagram, I am drawing the H parameter equivalent circuit. You see here VS, RS, RB will come, then HIE1 because it is connected to the Q1. So HIE, the input impedance HIE1 will come, then HFE1, IB1 is connected to the second transistor HIE2, HFE2, IB2 connected to RL, and across RL I'm going to take the output. See the current direction, the emitter current of Q2 is the collector current of Q1. So IE2 will be equal to IC1. Okay. So, but they will be flowing in the opposite directions when you draw the equivalent circuit. So C1 and E2 are connected, right? That's what is given here. See here, you have two current sources and the corresponding resistance RC1 in the present at the collector side resistance. So I am drawing the AC equivalent circuit from the circuit diagram. I'm going to short the power supply and the capacitance. I'm going to get the AC equivalent circuit. From the AC equivalent circuit, I'm going to have the H parameter equivalent circuit. See the current directions is given. This is IC1, this is IE2, and this is going to be RC1. And the current HFE2, IB2 will be flowing in the output circuit across the RL. RL is your load resistance.